Among these 5 lasers, we are going to discuss about semiconductor laser. Okay. So first let me say about what do you mean by semiconductor laser. Semiconductor laser, I can say it consists of 2 regions. Semiconductor laser, I can say it is nothing but a PN junction laser. PN junction laser, you can write it afterwards. Please listen to me. It is a PN junction laser. I can say PN junction, you might have studied in your lower classes. What do you mean by PN junction? I can say this is the region of P region and this represents N region, and this region can be called as PN junction region. This is the junction region, PN junction section or region. Okay, and you all know what are the majority charge carriers in P region, ma? Holes. Very good. Positive charge, holes. And what are the majority charge carriers in N region? Electrons. Very good. So now the majority charge carriers, and now I am giving forward bias to this. What do you mean by forward bias? Positive terminal should be connected to P region and the negative terminal should be connected to N region. So I am giving forward bias to this PN diode, PN junction diode. What happens? What is the working of it? I can say when the forward bias is given, the majority charge carriers of P, what are they? Holes. They will move towards this point, junction. And the majority charge carriers of N region, electrons, they will move towards this junction. And at one point, they get accumulate. What do you mean by accumulate? They all come and form together, or they will come closer together with in a minimum space. There will be more number of charges. That I can call that as accumulation, isn't it? So they all come and accumulate near this PN junction. Okay, when they come and accumulate near the PN junction, and I can say there's a chance for the electrons and holes to get, I can say this, I can draw an arrow mark such that electrons moving from P region to N region and holes moving from P region to N region and electrons are moving from N region to P region. Okay, at that point I can say at this region they have a chance for getting recombined. They can have a chance for getting recombined. I can say there is a chance for them to get recombined as a recombination process. That light is emitted, or in other words I can say photon is emitted, and that radiation is called as recombination radiation. So again I am repeating, it is a PN junction diode where when it is forward bias, majority charge carriers on both the sides, they will come and accumulate near the junction region, and they get a chance for there is a chance for them to get recombined as a recombination. That is a radiation of light which is called as recombination radiation. I can call that as light or a photon as ennan sollama. We can call them as recombination radiation. Are you all clear? Are you all clear? Recombination radiation. I can say there are 2 types of semiconductor laser. One is homojunction laser and semiconductor laser. Another one is heterojunction laser. So we are going. This is the basic principle for both homojunction and heterojunction. Are you all clear? So shall we go to the types of semiconductor laser? Okay. What are the 2 types of semiconductor laser? Homojunction and heterojunction. So let me draw this. You have to remember this diagram when we discuss both homojunction and heterojunction. Okay, so let me say semiconductor laser. Types of semiconductor laser. I can say this into 2 types. What are they? Homojunction semiconductor laser, and this is heterojunction. I am shortly writing this as junction semiconductor laser. Okay, homojunction and heterojunction semiconductor laser. So from the name itself it is clear, homojunction, single. Homojunction, single. If a semiconductor is made up of single element, if it is made up of a single element, I can call that as a homojunction semiconductor laser. For example, I can say, if I can write, simply I can write, usually you will have this short formation of nodes, isn't it? So single element for what my entry maluduna for both P and N type. Single element for both P and N type or N regions. Okay, here coming to heterojunction, it should be two different materials. Two different materials for P and N type. P and N type, okay. And I can give an example for this. For homo junction, I can say it is nothing but gallium, a semiconductor made up of a single element, gallium arsenide. Gallium arsenide. When you come here, example for this is gallium arsenide. If P type or P region is made up of gallium arsenide, what should be the N type, N region? It should be made up of gallium aluminum arsenide. Are you all clear? Yes? So these are the two types of semiconductor laser. So this we may get under 2 marks. Next is we are going to find out, or you are going to discuss elaborately what are the points you have to remember under homo junction and what are the points you have to remember under hetero junction. Are you all clear? Shall I proceed? Yes. So first let us see about homo junction semiconductor laser. So when you are clear about homo junction semiconductor laser, only slight modification in hetero junction semiconductor laser. Okay, the layers, we have only single layer here, there we have 5 layers, only those slight modifications. So you please be attentive in knowing the homo junction layer, which will be easier for you to follow the hetero junction. Chalk piece ma. Homo